Thanks for coming back. Before we start the actual video, I just wanted to let you know that for some reason, OBS messed up and I did not get any video recording for like the next 3 tutorials. So the one on design, the one on implementation, the one uh, on optimization, and then the one after that on testing. But the good thing is that, especially for the last two or the last three, I have plenty of videos on those on the channel. So if you need to actually see some walkthroughs on how to do each of those, just go watch those videos and you should be good. But the rest of it, you can just treat it like a podcast and just listen to it and you'll be fine. As for the design, you can still treat it like a podcast. I'm going to give a frame from the investigation method that just kind of shows you a sum up of some of the stuff that you might go through with the design, because you use some of the stuff from your investigation in your design. But if you really want to see me do a thorough design review, or what it might look like for me to design out an entire project, I have videos coming out soon on us building a healthcare app together. So you can go look at those videos and actually see me physically build out a design doc there. So without further ado, I'll get back to the actual video. But yeah, sorry again for not being able to record video for those. I just didn't want to lose all the audio because I do think it's pretty good and you can just treat it like a podcast. So yeah, I'll see you in the video. Bye. Hello, and welcome back to Deep Dive. So, here we are. We're about to start talking about the design. We were going through the idiot method, and we just talked about in the investigation part of the idiot method. And now we're about to talk about the D portion of the idiot method, which, is design. So, this is probably one where anyone in a corporate environment is fairly used to this. You go through a design review, and usually that involves you talking about your piece of code that you're about to develop, and then you present that to the team, you get input on it, and then you take that blueprint for your code and you go implement it, or you go code it up to go eventually into a pull request. So the design phase is actually pretty important. It's usually where you get full buy-in for your code and for your decision on how you're going to code it up. And it's often where people find out places that they didn't think about when they were kind of going through their investigation. So it could lead to a little bit more investigation work to find out what your proper solution is going to be before you go ahead and code out the entire feature. So, the design stage is very, very important. It's probably even more important than the implementation phase, because if you can nail things correctly in the design phase, then your implementation phase will actually be almost mindless. The implementation phase, you could almost, like, if you have a good design blueprint of what the code's going to look like, you could almost hand that to a consultant and they can go completely take care of it. And then, you use that code and integrate that code into your code base. But a poor design, you cannot hand that to a consultant. You cannot hand that to a stranger and have them go implement the entire feature. So something that is really well designed, a blueprint of the work that's going ahead, anybody could go implement that feature right then and there. So the ingenuity of any feature really comes down to the investigation and the design process. And like I say, oftentimes you're going to go back and forth between those two stages before you go fully into the implementation phase. We don't like to go backwards from the implementation phase to the design phase. That will delay your feature product by at least days. And in worst cases, it could delay your entire feature by months because you did not properly investigate your feature and you did not account for certain things as you were designing for it. So we truly want to we don't necessarily want to spend a long time in the design phase, but we want to make sure that we're due diligent as we go through designing some features. So one of the problem that we kind of had taken on in the investigation phase was that we were trying to figure out how to store this piece of data, and We were looking at kind of some of the trade-offs as we were doing our research, and we were looking through. We learned about this concept called a database, and we learned that there were like 8 different types of databases, and so we needed to go do trade-offs. So we watched a couple of demos. I didn't do that on camera, but assume that we watched a whole bunch of demos, and we kind of came down to the decision that we were either going to go with NoSQL or SQL. And so in the design phase, you can either write up a design plan that says, hey, here's what this code looks like with NoSQL, here's what it looks like with SQL, or you can make that decision and only present to the team SQL, but you need to explicitly say, here's all the reasons why I didn't choose this. So I'm going to go ahead and make a new file here. And so we'll call this the design file. And so in this design file, we'll just kind of capture some of the assumptions that we're kind of making going into this next stage, as well as what are kind of the decisions that we've kind of made here. So one of the things that I think is a really good thing to carry over is, this discussion that we had here on NoSQL versus SQL. So, and this is not what your design is going to look like when you present it to a team, but your team is probably going to have some kind of template. Always ask for it for how you're going to put all your data in. So you'll just need to format a section for these questions for your design review. And there's templates all out on the internet. Like I say, I'm not a high C person, or I'm not a super conscientious person. I don't have a lot of tools that I like to use when I'm displaying stuff. So this is honestly how I try to organize my thoughts. And then, I might rely on someone else that's made a template to just throw all my thoughts into that format before I present it to the team. So we might look up a design template kind of in this video. But so here we, like I say, in the design discussion, at least, I want to kind of bring out, hey, my decision is coming down to either NoSQL or SQL. Here's some of the things that I've considered between both, and then maybe kind of say like, some demos of what the code would look like. So you might have a blurb. You'll have a blurb of demo code in NoSQL. You'll also have a blurb of demo code in SQL. So you'll just have maybe a little image of a demo just showing, hey, here's what the user table looks like in NoSQL. Here's what the user table looks like in SQL. And that user table just, it's just composed of this stuff. So, of course, in the design, honestly, you want to restate the problem. And honestly, all of the stuff that we discover here, we just kind of tracked our investigation. So a lot of the stuff that we capture here is just going to go over into the design notes as we just tell people, hey, so here's the problem I was trying to solve. I investigated 8 different types of databases. And then, came down to 2. And, I need your help in deciding which one to use. Here's what a demo of what the code would look like. And then, pretty much from there, you just ask what people's opinions are on and like I say, these are the kinds of questions that most people are going to care about. Some of these questions, like does it look easy to use and how much work to maintain, are going to be questions that seniors on the team are going to be able to answer better than you, unless you yourself are a little more senior or just more experienced dev. And then so even these questions their answers might end up changing just in the design meeting, and at the end of the discussion you'll kind of have a solution to this. And honestly, that's it, right? So now, some design meetings can get really, really complex. So in our case, we kind of actually have a fairly simple problem, but let's just say that we were facing some completely different problem. Like we needed to kind of, and I would never advise this as like an individual deliverable, but say that you have to go build an entire system. So say that you need to go build a social media application. Right, so you've been commissioned either by a client or by your team, whatever, or just this is a personal project for you, and you just said, hey, I need to go build a social media website. Now, social media websites kind of follow a certain kind of trend. They all need databases. They all need, usually in today, they're going to need some kind of API. And usually that's going to be a REST API. They're going to need a web interface or some website to go along with it. So, and I'll just write that out. So task, build a social media site. And so, like I said, common things needed is a database, a front end. It's going to need some kind of API. And I mean, and there's honestly a lot more stuff to go into it. Like each of these parts can be broken out into different things. Like an API, is going to need like an SSL cert. You're going to need a VM setup, deploy and setup. You're going to have to code this in some language. So choose a language and framework. And some of the same discussions here. It's like you've got to, decide all the data schemas. You decide the framework that you're using. And then, even that, like where are you going to deploy? And then with your front end, what UI framework? Are you just going to use like plain HTML and JavaScript, or something like React? And the list goes on. Flutter, whatever, like Pure, whatever. I mean, and even sometimes on the front end, like are you going to hire a designer, right? So maybe it's so much work that you're just like, shoot, like this is 40 hours of work. I'm going to hire someone to go do this. It cost me like $500, but and then I'm done with the problem. So, yeah, so I mean, these are just like very, very preliminary questions that you'd have to ask, and this is a huge endeavor. So to kind of bring something like this to a design meeting, I would kind of say, I don't like it, but there is a way to kind of bring a big problem like this to a design meeting. Honestly, I would in the first design meeting, I would say, here's the 3 main tasks. Now go back and investigate each one and then make a design doc for each one. And so in our case, you can see that the problem that we're discovering right now is the database problem. So what we're designing out right now is a sort of database, and you could easily think about how to adapt the investigation and research that we've done so far into designing out this database deliverable. So in essence, what I've just shown you is not that different from a major large scale design. It's just that we found a way to break the large design down into a much smaller design, and that's the divide and conquer tactic. You might already be familiar with it from computer science, but it's always important to kind of figure out these high level overviews of your entire project. And even if this were like a giant deliverable, which I would say that's insane, but if this were in just one giant deliverable, well, at least you will do the work like you're traveling the tree, right? You'll just do the work of investigating the database. You'll make the design doc out for the database, and then you'll present it. You'll present it to the team with investigation already done for all these other ones as well. So it'll just make a much larger design doc. So much longer meeting, I think very inefficient, but sometimes that's all you can do. So, but yeah, here's one where you can, and this is also an example where people will tend to overcomplicate stuff, in many cases to make themselves look smarter. But, this is an example of a place where someone really would think about, they might have all these like schema diagrams and whatnot, but the reality is most things can be done in parallel and don't really affect each other. So, for your API, when you're thinking, you don't really need to know what your entire API is going to look like at the very beginning, and most likely you won't. Like your list of features are going to evolve as you create it. So, but the first endpoints of an API are probably going to be like serving the home page, and then like a login, logout system. So, not saying that they're going to be UI. They might not map to explicit UIs of their own. Nowadays they probably wouldn't. But those are probably the main endpoints that you're going to need to code in your API at the very beginning. So it's not this huge thing that requires like 50 different classes to implement it. It might be a very simple, like this one is just very simple auth class, and maybe a very simple auth database. And then this one is maybe not even a class of any kind. Like it's just routing you to some HTML text file. So the route literally is just directing you to an HTML file, and it's not even doing any processing through a class. So, that's that's where you should start. But you should be very hesitant. For some people, and we'll go to the internet for this one. In design, we have these diagrams, like a UML diagram. And these diagrams can get super complex. So here's a good one. Right, so some people will try to present this at the very beginning of their project, and they'll be like, okay, like, at the very top, we'll flow into this, and we'll flow into that, and we'll have, and these will all be different classes and different implementations and stuff. Here's a really good one of an actual UI, and what people don't realize is that things like this is what your diagram should evolve into, but it should not be what it starts out as. And I make that mistake a lot. Like it's one of my power. It's when you kind of have a lot of power, so you tend to kind of overdo it. You don't like to start from the very beginning on stuff. But the reality is that you do need to grow. You need to grow naturally from the first problem that you solve. So the problem you're trying to solve is authentication, most likely when you're first starting a server. So your UML diagram should really only have an authentication class here. Now, if you don't know what a UML diagram is, I mean, it's essentially this, but unified modeling language. Go to Wikipedia, look it up, come back to the video, and like continue on. It's how we diagram out the architectures for our projects. If you have no concept of what that is, this video is too advanced for you, and you should kind of, spend a little more time coding and kind of come back to a concept like this. Like you might not really understand the motivation behind designing out your system, and I can tell you the motivation, which is just that it makes things a lot cleaner and easier to understand. But you're not going to understand that viscerally until you have fully gone out there and tried to code a full project. So I would say give 20 hours to a good project and then come back to this video, and then you'll truly understand, okay, maybe it would be nice to diagram something out at the very beginning and then continue to add nodes onto that diagram as my project gets a little bit more complex, so I can kind of understand the flow of things throughout my entire system. So, but yeah, the main point here is that these kind of diagrams are not the things that you should have at the very beginning of your program. Honestly, this one is not too complex. It's not too complex, so you can kind of see how it's labeling out what the database schema is, and it's going into like what the interface is going to have in it. So you could kind of argue that this would be an okay diagram for an initial problem, but I would just say make sure that you don't go too much further past this. So it looks like in this case, like they're building some kind of interface for kids to enroll in their classes. And so they just have these data types here of student, address, professor, and course, and maybe even a seminar. And then they have a class. Oh, okay, so no, the seminar is, and here we mostly have a class that's kind of trying to be the joiner of a lot of these things. I would tell them to not implement it this way, but that's that's personally me. Like I said, kind of keep the data separate from the functions that it's gonna do. This would be pretty difficult to ever translate into like a database easily, because you're gonna have to pull away. Like you could maybe technically store the model inside the class, but I would just say let things kind of flow. Don't make restrictions on your code, like arbitrary restrictions on your code that you don't need to. So these don't need to be tied together. They can be just single responsibility of this person's probably super smart, but I don't know. It's my personal opinion that it could be a lot cleaner if these were just separated out, and maybe I could look at this. This one passes. Like, okay, I could see you validating a struct and outputting as a label, but this I don't like, because you're like getting information like that. What is that? That a call out to somebody to get that information to fill in that struct? It's like the professor isn't responsible for filling in itself. Like, let something else fill in the professor. Like, just let it be an empty data struct. But anyway, and this would be a valid opinion I would give them inside of a design meeting. I would just say, hey, break this all apart, and let these be kind of classes that exist by themselves, so that and by letting them be classes by themselves, I get to share these relationships, or I get to share kind of the function definitions with other pieces of code. So this one has get information, but maybe I also have a get information call for student. So, they don't necessarily need to be completely differently defined functions. Purchase parking pass. Well, see over here how the student also needs to purchase a parking pass. And because they don't share any kind of hierarchy, or at least it's not very clear from here that these two share any kind of hierarchy, which might really be member of school, then they can't really share any implementations on their part, even though they might have the exact same purchase pass, parking pass. So that's so that would be a critique I would give in a design meeting if I saw a diagram like this. But I think that this is actually a fairly good representation of how you might code out a system to begin with, right? So just an overview, they're giving you kind of all the data types that are going to exist in the first prototype of the system, or the proof of concept as we call it. And then you have kind of some of these class-like things like seminar enrollment and seminar. So really you have this kind of class-ish thingy that's a seminar enrollment that's responsible for joining everything together. So so I would just tell you, feel free, make whatever diagrams that you want that kind of communicate the ideas that you want. And all diagrams don't have to be the same. Like, as you can see, many different people have tried different things. So make your own diagrams, and just try to get them to work how you think, and then bring that to the team, and then they can kind of give you critiques on a more universal way of creating your diagrams out. And I might do a video more talking about how to do diagrams. Like, I tend to just draw mine, quite honestly, but I draw mine on a sheet of paper, and then I just show out the entire system, and I'll show that more in like a live stream kind of setting. But you can just know that with a design, UML diagrams are sometimes something that people use. Sometimes people don't. Sometimes people just write out all the functions that they're gonna write out, and all the parameters that are gonna go into that function, and then they write out like all the structs. Some people will just go code up all the structs and then show it to you in the code of like, okay, here's all the data types I'm going to be using. So these are kind of what people would call contracts. So these are all the contracts for the APIs that I'm developing. So, and one thing to kind of keep in mind is that people say APIs interchangeably with library. So, or like a function. So a function has a set of parameters to it. And, so you can kind of think about that function being an API. And oftentimes, when you're just starting out and you're building an API, say in Flask or .NET Core, and you have this API and it's like, oh, it takes in 3 parameters in the API. Well, if you catch on pretty quickly, what you end up doing is like taking the 3 parameters that you take in, either in like a JSON or, some other format, like in the Git header, you take the value of those 3 and you feed them into a function. So in essence, you're doing what's called proxying or adapting that function to this framework, which is the framework handling the web request. So your web request is coming in as a JSON. That's the object, the data store. And then you're converting that data, the entries from that data store, into something that your computer can read. So you know, if your JSON comes in as all strings and you can just pass in 3 strings to your function, then yeah, you're just proxying that information into your function. So in a way, your function is still the API, right? Because it's but yeah, you know, and I think that's a connection that people can sometimes not get, because their APIs are actually very complex. And I know that that's how mine were at the very beginning, is I did like 100 lines of logic for every single API call. But over time, my APIs actually got really simple, or my outward facing endpoint code got very simple. Like the endpoint, when you called my make account endpoint, all you do is go to my like user factory, and I just, you know, you call my user factory get user function on the JSON object, right? And then that function just handles parsing the JSON object into whatever it needs to, whatever it needs. But and then that I just end the API call, right? So it gets a lot simpler than before, which was like, okay, I'm cracking open the header and I'm validating the header to make sure it was a valid user token, and then now I'm formatting the request, and then I'm doing a SQL query inside of here, and then I'm making another SQL query to create the user or something, and then cache a token, and then I'm formatting the response to send back, and then I'm doing all that work just inside of the actual API code. And so that API code, for people that might not be familiar, is something like Azure Functions. So if I come down here and I make like an Azure function, cloud general, Azure function, cool. So HTTP trigger, cool. So yeah, if I come down here, so you can kind of see what I'm talking about, how, you know, if you're not careful, you can end up, you know, you can do all that work here. You can end up cracking open the header here. You can query a database and all that stuff. But, you know, when you get real elite, you'll have something is like user factory dot get user, and it'll just take the request object or something and then do all the work that it needs to do from there, right? Like, and that's what your API code will look like. And so that's what I'm saying. It's like, this is what we would just call this an API, because, you know, this is not, I mean, yeah, like this is the technical API. Like this, when you do the test, when you hit the test endpoint, you're going to come into this code, which is an endpoint, it's an API. But then yeah, you're going to proxy all the information into this function call. So the function is an API. So anyway, so like I say, there's a lot of different ways to go about kind of making a design doc, as we're calling it, like here. Like I say, this would be plenty though if you were to make a design doc for me and you wanted to say, hey, I'm thinking about using the user data, or here's how I'm thinking about storing user data, right? And I investigated these things. It came down to this one. Here's what the code looks like for both of them. And I already have cost estimates of stuff. So, you know, and depending on if you're acting like a product manager, you might be giving me real numbers. Like you might come to me and say, hey, NoSQL is going to be $10 for a month, whereas SQL is going to be $100 a month. Like, you're going to give me real numbers, and we have those kinds of decisions. But those aren't usually decisions that devs are going to make. So don't worry about that. But, you know, if you're working in more of a startup environment, you might be expected to bring those kinds of numbers to me, and then we could kind of talk it all out just as part of the implementation discussion. So, and like I say, so, you know, this is, like I say, a very basic way of making a design doc. We showed you a more complex way, which is involving UML diagrams, where you actually go into talking about all the classes that you're going to implement and the structs, and you start making the contracts that you're going to have between each of these different calls. And the contract is just a way of saying that these will, this struct will not change. So this struct will always come to you with these values. Where was that other one? Yeah. So, these are my structs, and they will always be formatted this way, so that when the student goes to the seminar enrollment, it will always have the student's name, phone number, email address, student number, and average mark. So it's like, we know I would tell this person to keep something like average mark out of the student database, because that's going to get called way more than any of the other data. But yeah, it's just like, yeah, this is all a contract to the other methods, everything inside the code. Honestly, it's a contract saying that, hey, when you get a student object, these things are going to be in tow. So you don't have to worry about that not being there. And you know that if something is not there, so say that the student's address isn't here, then you know that, okay, well, I need to go find another table around here. Oh, okay, cool. The address table is going to tell me where that's going to tell me where the student might live. So yeah, this is a contract that we're establishing very early on, so that we can kind of code around it, and we can say, okay, either I need to add, if I say that we weren't tracking the address, then I might say that, okay, maybe I need to add that to the student class, or maybe I need to make that a separate class or struct on its own. So anyway, so that was a more complex way of how to design out your system, and you certainly can do that. Try them all out and see what just really works for you. And then we kind of came down here also and just talked about what it would look like to design out a very big project. So, and the point out there is that big projects are really just a collection of small projects. Here's what a query we were faced with a huge obstacle of build an entire social media website. Well, we saw that breaks out into 3 problems. People should already know what the first problem looks like. Was just the exact same as the problem that we had already solved. And your API is going to look almost identical to what your database is going to look like. But here's really just think about your API is manipulating the data, and the database is storing the data. So and then, guess what the output might everything look like. Needs to look very similar. And so we show these in our otherwise code, you have some big issues, or in our design doc. And if you have a really good front end, there's really no discernible difference by devs, and it actually looks pretty. We don't really care about performance. Almost identical. Maybe it just comes down to that we just care about the cost. Kind of you kill cheaper and easier to adapt with. As we move forward, because we don't have a very good idea of what our database is going to look like. That is pretty much going to be we end up kind of making that decision that, hey, from here, I don't know what my database is going to look like in the future. I need something that's super easy. Let's just assume now that we've discussed with the team how much work to maintain. This is what it looks like. Really, really easy to maintain. And that's really I'm deciding between NoSQL and NoSQL ends up winning, and I have a blurb of demo code give you the green light. So if you just go ahead with your implementation of it. We'll have to look up an actual one. So yeah, now you're done. An example of with your design phase. And like I say, you can really breathe a sigh of relief at this point code, because this is probably honestly most of the hard part is done. I would say that you might still have more difficulties here if you're unfamiliar with the technology that you're using. So. Like, let's just say that you've never used NoSQL, you never used the database language before. Okay, now you have to kind of teach yourself databases, and so you might have to take a couple of classes. But if you've coded in databases before, you're familiar with the language that you have to code in, the implementation phase is actually not. You almost go to sleep while you're coding it out. You go into a state of flow and you go ahead and complete all this code pretty quickly. So I'm going to talk about the implementation phase next, but I'm not going to spend a lot of time on it because, like I say, it's I've got plenty of videos just talking about implementation. So this is implementation. It's just I'm pretty much going to be rehashing the stuff I've already talked about on the channel, but it can still be useful to kind of talk about. Like I say, it's the most exciting part of the code for a lot of people, but the design and the investigation part of a project are by far the most important. So yeah, I hope that this was at least a little bit helpful for understanding how you might go about designing something. Like I say, apologies for not having a really nice, cute template to give you, but not really how my brain works. And there's plenty of templates already out there on what a design doc might look like. So credit to these people, but you know, you can go find someone's like Word doc that they poured over and just copy it and throw all your data in here. But honestly, these are the guts of a design doc. So even if you present it to someone in a notepad and got input and buy-in on your decision, like, you know, the work is done. So anyway, so I'll be meeting you back to talk about the implementation phase of the idiot method. I'll see you in the next video. Thank you.